All right, let's see. Okay. Hey there, Kendall. I'm not sure if you got kicked out. You can move to where are you? Breakout room 3. All right.
Anything, man.
There,
Oh,
that works.
well, I can't see anything on the site, but they can. What do I do?
Power. Are you in the Google Slides?
Oh, it's a Google.
Bruh.
You need a link to it?
Bro, I'm tired. Okay, give me a break.
Okay.
The last group was making me laugh. Where are you guys? This is interesting. Are you all still working? Okay, yeah, it's interesting. I like where you're headed. All right, we'll take some more time. How are y'all doing?
But good.
That's good. All right, I was just checking. All right. Hey there. Let's see. You guys are room 4. Interesting. Are you all still working?
I think we've agreed upon the way that we want to organize them by color.
So is it done? Is this your final?
Yeah.
Okay. Okay. All right. Well, you're going to take another moment or two. This is group 5. Hey, group 5. This looks fantastic. Do you have someone in here that can explain this when we come back together, what you did? Who's in here? Awesome. This looks great. All right, we're going to take another minute or two, and then we'll come back together. Group 2. Group 3. Who's in group 3? Oh, group 7. I didn't know there was a group 7. Oh, hey there, Keaton. Are you still in here? Oh, no. All right, so we're going to take...
She's just staying there.
Hi there.
Oh, hello.
I didn't... Wait,
Oh.
What room is this?
We were one, but
I thought so. You confused me.
someone took the first slide, so we went all the way to the bottom.
Oh, okay. Then I was confused. All right. Are you almost done? Could you be done in a few minutes?
We're done, I think.
Oh, you're done?
I'm pretty sure we're done.
Okay. So I'm going to just make sure everyone else is good and we'll come back together.
Aye, aye,
Alrighty.
Captain.
You guys were done. Let me just double check. So it's only... Hey there, everyone. Welcome back. I'm sorry that was kind of abrupt, but it looks like most of you are done. Let's take a look over. Let's take a look. You guys were some of your rooms were very funny. Let's take a look at them together. So if we go into the first slide, so everyone head over and take a look at the first slide. So I see someone wrote up there. Does anyone want to tell us how you decided or what you did? Go ahead. Go ahead, Colby.
Yeah, so pretty much what we did for the candy periodic table was we categorized the columns by the color. So gray is the one column, and then yellow, and then red, and then blue. And then in the rows, we categorized by like this specific shape and size. So the one row had circular candies, and then gummy bears, and then gumdrops. And yeah, that's pretty much how we categorize all the candies into rows and columns.
Awesome. Thank you. That looks good. All right. So we got size, color. All right. Let's look at room 2. Someone in room 2. This looks interesting. Want to tell us what you did? No? Well, room 2 looks fantastic. No one wants it. Let's go to, well, I'm going to come back to you all. All right, let's come back to room 2. I'm guessing room 3 is someone in room 3? No. So let's go to slide 4. I keep seeing color and species. Yes, I'm going to come back to that number 2. How about 4? Slide 4. Looks like someone was in there. What'd you guys do? You did color. Okay, so you just did column colors. All right, so we got colors, we got size in the first one. And slide 6 is no one. Slide 7. What did you all do? Slide 5. Slide 5. Okay, we'll come back to 5. Actually, I think I did that on purpose to be awesome. To be completely honest. Let's come back to 5. Let's look at 7, and then we'll go back to 5. So 7. Anyone want to tell us what you all did? I don't think so.
I don't know if anyone's gonna jump on, but to be honest, we just did it by like type of candy because I don't know.
No, that's good. So we have color, we have size, we have type of candy. So that's good. We have some organizing that way. All right. Let's go back up to slide 5, which I think is really similar to slide 2. They're similar. So someone from 5 want to explain what you did?
So we assorted the candies by color for the rows, or columns, I'm sorry. So columns is color, so like gray, blue. And then we did the type of candy for the rows. So we got the small ones, the gummy bears. There isn't a lot of information to sort them on, so we just had to do like a table thing.
Good. I'm going to grab one more. This looks really good. You all can hang out here. I'll be right back with you. Although you could still hear me. You could stay in that slide. I'm going to grab slide 2 and put them side by side if I could. Does it work? It works. All right, so on the right-hand side is slide 2, and you can see how similar it is. So why are there spaces in these? Anyone from the groups want to? They are. I took some away from you. Some of the candies are missing, right? And I did that purposely. Yes. And so this is exactly how Mendeleev, who was a scientist, put together the very first periodic table. He got all the elements together and he sorted them by property. So some of you did color, some of you did size, some of you did type of candy, right? And so he organized them that way and then tried to line them up into rows and columns, and then realized if he did it a certain way that they wouldn't be particularly in order, right? To kind of throw things off. And so he left spaces where he knew, hey, well, I don't have that candy, or I don't know that element, but there must be an element that we haven't discovered yet. And I'm going to leave a space for that. And hopefully some scientist somewhere will discover it for us and let us plug it in. But he left spaces in his table too, because he said, okay, well, I'm going to organize these and everything's lining up and we're just missing that one. So let's leave a space. We'll find it later. It's probably out there somewhere. Yes. And we'll see. And so that group that only, that sorted by type of candy, that was one of the items too, right? So we're going to see that everything in the same group has the same properties. So just like that same type of candy was all down the same row, really similar to the periodic table as well. So this all works: color, size, type of candy, but then also the holes, leaving those spaces where you know something should be, even though it was taken away. Awesome. You went to college yesterday? Where'd you go? Tell us about it. And they were talking about the periodic table? Are you taking a class? Oh, it was a... I'm not sure what that is. Intern? Yeah, what's a griffin? It is cool though. That's awesome. Oh. So silly me. I get it now. I know Griffin. So you were just there for the day. That's cool. You were talking about the periodic table for the day? Well, that's cool. I thought it was some kind of program. I was thinking of, oh, we go to, a college program. Silly. All right, so let's go back over to the classroom slides. So you could put the Google thing off to the side somewhere, and we'll take a look here. So this is a really good note slide. Let's see if I can scooch this over a little bit. This is a really good note slide. It talks about Dmitri Mendeleev. So he was the first person who came up with the very first periodic table. And what he did, so at the time there was elements that were discovered all over the place, different scientists, and at the time communication was not as good as it is today. Obviously there's no cell phones, or I don't even know what year phone was invented, and not as much travel and easy to get to each other. And so what he did is he went around and found all the information about all of the elements that had already been discovered up until this point, and maybe made cards out of them, and like we had candies, and try to arrange them and put them in a way together that made sense, that organized them by properties. And when he did that, you could see this is his first table. It's definitely smaller than what we know is the table today. But when he was organizing, he saw after every 8th element, it seemed like everything repeated. So he ended up having 8 rows, or 8 columns. For us, it looked like a lot of you had per candy or per color, and I'm not sure. So 1, 2, 3, 4, or 5 different columns based on color, or different columns based on candy, but that's the same idea. So he found after he got to that 5th candy or that 5th color, if he went back to the beginning, he was able to line them up by that color again, or by that candy again, or by that property. And so what he did, if you take a look, there's question marks in here. And so he said, okay, I don't have anything that's lining up in here now, but there must be another element out there that's missing, because I know that all of these in this column should be red, and I'm missing a red one. So I'm going to leave a space right there where an element should be. And that's that last point there. And so once he had this together and he shared it with the scientific community, scientists were able to go out and say, okay, I know that an element's missing, and I know it's right here, so I know all the properties. I'll go look there and discover that element, find it in the periodic table. So anyway, he's credited with coming up with that very first periodic table. This is what, so this had eight columns. No problem. This is what the periodic table looks like today. So there's 18 columns now. And again, organized though by atomic number, we know. And it's the way we kind of put everything together. And we're going to see that the periodic table is like the best cheat sheet in the world, because you're able to use it. You're supposed to use it. And we could clearly see the element names and some of the numbers and the colors, but actually we're going to learn about why they're organized, why they're in the columns that they are, and the rows that they are, and so forth. This is a look here. Again, there's more columns, more patterns, or repeating patterns. And that's why the table is called a periodic table, because there's periodic patterns that are repeating after every so many rows or columns. We'll come back to that in a second. This is what the full periodic table actually looks like. It's really long. Those 2 columns in the bottom are supposed to be up in rows 6 and 7. And the only reason why we don't see the periodic table like this often is because it's just too hard to work with. It's so long, it doesn't fit on a regular piece of paper, then it makes all the numbers and letters really small. And so we usually take out those 2 rows right here, and we pull them to the bottom of the table. And those rows are a lot of elements that are rare, they're radioactive, man-made elements. We don't typically talk about them a lot. And so it's easy to just pull them to the bottom of the table, smush everything together, and make it just look nicer and be on a regular piece of paper. And that's really the only reason why they do it. But the periodic table is that long thing. Those 2 rows should be up in the center. All right, this is a little old. I just changed the date, so some of this stuff might be on the older side. But you could think of the periodic table like a calendar. And let's just say every Sunday we watch games in here. We watch football. Every Monday, maybe we work out, and every Tuesday we have a piano lesson and so forth. So you can see as you're going down the columns, just like you were arranging the candies straight down, they are all the same type. As you're going down the column, you do the same thing every day. And then when you get to Saturday, the calendar, the week starts over again, and you repeat that same pattern. And so we call that, the reason why it's called a periodic table is because we have those periodic patterns. The same thing is happening on the periodic table. It is. I like pizza night too. Keeping our calendar in mind and looking at the periodic table, I just put a few things in here that we're going to take a look at as we go through the unit. But everything in this first column are soft metals. We saw a video on that actually, and I have another one to share with you today. But as you go down that column, they all share the same properties. And then on Tuesday, all of these elements are soft metals. They're just not as soft. Kind of soft on Tuesday. And then by the time we get to Saturday all the way over here, or Sunday all the way over here at the end, these are all gases. And so you could think of the calendar kind of like the periodic table. It's that repeating pattern. And every time you get to the end of the week or the end of the table, you go back to the beginning and the pattern starts over again. And so as columns, elements in columns share a lot of the same properties. All right, and one more slide before we practice a little. Again, a note slide. These are the first two vocabulary words. So groups and periods. Groups are columns on the periodic table. And if you, maybe at the college yesterday, or maybe in some old textbooks, sometimes they were called families as well, because people in the same family share a lot of the same properties. So they used to be called families, now just called groups. But as you go, each column in the periodic table is a group, and they share the same properties, the elements in the same group. The rows going across are called periods. And we're going to say, to make things easier for us as we're just learning, that atoms in the same, or elements in the same period don't have the same properties. So you can make a case, like if you went to potassium and calcium really close together, and you could say, okay, they're both soft metals, they're both metals, right? So you can find some properties that are similar as you go across the table, but we want to think of it as the entire table from beginning to end. We're starting off with a really soft metal and we're ending with a gas. And so we're going to say as we go across, the properties are different for now. You can know again in the back of your head that you can make a case that some properties are the same as you go across. But to just keep that whole idea of that repeating pattern in the calendar, we're going to say as we go across the period, things change, things are different, and think of it as the whole way across and not just right next door to it. All right, so let's try one or two. Let's see what time it is. Let's try one or two of these, and I'll see how long the video is. And maybe we could pick up tomorrow. We'll see. All right, let's try this one. And I'll take a look at the...
Grammarly's top 3 tips on starting an essay.
Let's say you're struggling to put pen to paper on an upcoming essay.
Okay. Looks good. Awesome. I think we're good there. So element that is in the same group as beryllium is magnesium. Awesome work. Right? And so they share the same properties going up and down. Go ahead, Colby.
I had a question about the groups. So I see here that in this picture, they name them 3A, 4A, and 5A, and 6A. But on my periodic table, it says it's 13, 14, 15. So do we name it the 3, 4, 5 because we skipped the transition metals? Or do we name it 13A, 14A?
Yeah, I didn't realize I used this table. This is coming up. But I'm going to flip forward if we look at this table. So if you take a look at this periodic table, at the very top, there's actually 3 different sets of numbers. And so if you start with 1 and count all the way over to 18, which is what your table is doing, it's just counting them 1 through 18. So there's a total of 18 groups on the periodic table. The groups are also split into 2 groups. If we take out what you were calling the transition metals here in the center, we call those group B elements. Sometimes they have a B on top, so you could see, I know it's really small, but this is saying 3B, 4B, and so these have the letter B next to it. And we don't really count the ones at the bottom, so you could say they're Bs too. We really don't do that. But the ones that are left, so the first 2 columns and the last 6, those are your group A elements, or you could call them representative elements. And so that's where the 1A, the 2A, and then skipping over to the 3A come from. And they do it with regular numbers and Roman numeral numbers. So you could get Roman numeral 1A and Roman numeral 2A, or just 1A, 2A. There's a lot of old chemistry, and so they have Roman numerals and different prefixes, and when we start naming things, there's kind of old stuff and there's newer stuff. So you might see some periodic tables like this where they have all 3. And we focus, I keep saying elements follow the rules or don't follow the rules, and so we're focusing on those representative elements, those group A elements first, because they're going to follow the rules. And then we're going to go to those transition metals in the center. That's a good question. I didn't realize that I had done that, but I did. If we go back there and take a look at this one, that's also going to correspond to the number of valence electrons that an atom has. And so our warm-up question was chlorine. And we know chlorine now is in group 7A. So everything in that column is going to have 7 valence electrons. And so now we don't have to look them up anymore or write the configuration anymore or figure it out, right? That was just so we can learn and get a good idea of where these electrons are and, you know, what the letters, the S's and the P's and all that mean. But now that we could read the table, we're going to be able to look up a lot of this stuff. And so those numbers next to the A's tell us how many valence electrons there are in those atoms. The ones in the center don't follow the rules, so we can't do something like that, but we could do it for the outside ones. All right, where are we with time? Let's see if we could watch the video and then we can end there and we could pick it up tomorrow. So what I'd like to do, the video is about 2 minutes and it's going to show you the elements in this first column here. So hydrogen's not included because it's a gas. It's an exception to the rule, so we know that things down the same column share the same properties. Hydrogen's a weird one though. I could talk more about it later. The reason why it's in the first column is because it has 1 valence electron. But it's obviously not a metal. It's not solid at all. And it's simply there because of the number of valence electrons. If you look, I don't even know if you can find them anymore, but really, really old periodic tables, they might have hydrogen in the center of the table because scientists couldn't decide what side to put it on. Some were thinking it should be here next to helium, right? Because then it's with all of the gases on the right-hand side and so forth. But the scientific community finally said, okay, we're going to leave it over here because it has 1 valence electron. So most of the tables show it there now. All right, so you're going to see the rest of them. And we saw some videos. We saw cesium before, and I think we saw sodium. But this puts them all together and adds some more properties to it. So again, it's about 2 minutes, and then we'll wrap up and pick up tomorrow. I forgot. My whole brain just left me. Forgot how to put a video on it for a second. Oh, Lordy. Here we go. All right, here we go.
There are 6 alkali metals: lithium, sodium, potassium, rubidium, cesium, and francium. They're all soft metals which can be cut with a knife. In air, the elements quickly become coated with compounds that form on the metal's surface. Here, for example, is lithium. When we slice it, you can see the metallic luster, but the black coating quickly reappears. Sodium is kept under oil to prevent reaction with air. Again, when we cut it, the metal surface can be seen, but this time corrosion occurs even more quickly. With the next alkali metal, potassium, the corrosion in air is so quick that it's hard to see the metallic luster at all. As we go down the group, the elements seem to react more quickly with air. Now let's see another reaction of the alkali metals, the reaction with water. We'll start with lithium. The metal floats on the water and reacts with it, giving off hydrogen gas. Now for sodium. The same sort of thing happens, although the reaction is a bit more vigorous. All the alkali metals react with water in the same way. Let's see an equation for the reaction. Hydrogen gas is produced, and the metal dissolves to give an aqueous cation with a single positive charge. Now for potassium. This time you'll see a flame. The heat given out by the reaction is produced so quickly that the hydrogen gas catches fire. It burns with a lilac flame. The next element is rubidium. This time we put a safety screen between us and the reaction. You can see that things gradually become more terrifying as we go down the group. Let's try cesium, our fifth alkali metal.
It is a little dangerous. Do you remember we saw another video of that a while ago? You probably don't remember, but I could go find it. It just showed two different metals. I actually forget what we were talking about at the time. But you could see, so just like we were arranging the candy, everything in that first column shared the same properties. So if we go back here and let's see, let's go to that one periodic table that I was sharing with you, this one. And so they had mentioned alkali metals at the beginning of the video. So all of these elements in this first column are called alkali metals, and traditionally there's keys on periodic tables. So you can see at the bottom it tells you the pink ones are alkali metals and so forth. There's 4 columns that have names, and they're again usually color coded that way. But the alkali metals, they all shared the same properties. So they all reacted with water. They all were soft. They all could be cut with a knife. They all reacted with oxygen in the air and tarnished really quickly. You could see when you first cut them, you could see that shiny metal. So even though they're soft metals, they're shiny, like all metals we'll see are shiny, but they just react really quickly with the air and they tarnish really quickly, where other metals don't do that as fast. But anyway, that idea. So everything in that same column shares those same properties. All right, let's leave it there. We'll pick up again tomorrow. I'm going to have to adjust the schedule a little bit, and I had these homeworks there, but I'm going to change the date on them because we didn't get through everything, although you probably could do them, but I'll change the dates and we'll just pick up tomorrow. Right, have a great rest of the day, everyone. Half day tomorrow, so I'll see you earlier. Bye, everyone. Bye-bye.